So thank you very much for coming. My name is Jack Whitter-Jones. I'm from the University of South Wales, and I'll get to that now. So what my presentation is about is how we can actually make a little phone, this little phone, for $29.99 from Asda's, to do some interesting and weird and wonderful things that can be useful for red teaming and investigative journalism or various other areas, but on a sort of a shoestring, so you don't need to break the bank to be able to make a red teaming engagement go through the roof. So, like I said, my name is Jack Whitter-Jones. I also go by Exit. I'm from the University of South Wales. I'm doing my PhD in security operations, and I teach the arcane art of PHP as well, which quite a lot of my students don't like. And then the other guy that was supposed to be here, Mathew Evans, is a security researcher as well. And he goes by Monk. Some of you may know him already. And if you want to see our blogs, they're all up there. So, what is this talk about? Well, it is about this little phone and the process that we've done to be able to develop it, and the reasons why we got to this point, and then what we've actually gotten in the end goal here, and the hurdles that we've done. So with me and Monk, there's always a question of, can we stick Debian on a device? We've got pretty successful at that point in doing, we can put Debian on almost anything other than a Cisco router, because they just don't like us. So we thought, could we actually put Debian onto a phone? Well, that's been done quite a lot already. If you've seen Kali Net Hunter, that's a Debian base. And they use Ch-ch-chroot and CPIOs to be able to do tooling. But the problem is, when it comes to actually doing something a bit more covert or sneaky, Kali Net Hunter becomes quite expensive and is quite noticeable. You need a fairly powerful device like the Nexus, which can set you back quite a bit if you're doing a red team engagement, if you're like an SME, for example. So we thought, how do we sort of make this a bit better? How do we improve this? We came into quite a lot of hurdles at this point, and a lot of the time, SE Linux was one of the causes that stopped us carrying on our development, because you can't actually stop it from working. SE Linux will always be on the phone. It says passive, but it's still running, and it'll still stop you from doing weird and wonderful things. And then one of the common forensic methods to be able to detect the phone and be able to interact with the phone in an investigation is using what's called the ADB bridge. So for anybody that's done it before may know, the ADB bridge is just a common port where you can connect to it. It'll then give you the underlying operating system, like if you're connecting to like an SSH, for example. So our aim was to be able to disable that, both permanently, but also remotely, being able to turn it back on and off. And then adding further functionality and anti-forensics, because we want our device to be able to help those investigators and red teamers, but if they're caught, you don't want them to be then risking a situation where they could be compromised and it could ruin the entire red team engagement, or it could ruin their sort of investigation that they're doing. And then the other point is that with storage limitations, you don't want, because most IoT devices and mobile phones limit on storage, you don't want to take up a massive amount of data, which could be spent on doing like videos or photos or recordings. And then we also want it to be affordable. These are pretty much all the main goals. So we came to the ideal scenario. So this is an Alcatel Pixie 4, I think, if I remember rightly, which is a full Android device. You can take pictures, you can do all the good stuff. It's cheap. I got it from Asda for $29.99. It's fairly deniable. Most people have two phones these days. I mean, you could raise a flag saying, why have you got this really, really old phone? But and then it's easy to root, so as a proof of concept, it makes a really good way of doing something. It's really easy to use, it's quite intuitive, and it's also running Android. So those are the ideal scenarios, and that's why we came to this phone as our main goal. So our first process was, right, Debian is massive. What can we do to make it a bit smaller? So what we've done is use TinyCore. So TinyCore comes in 3 or 4 different components. which are all ranging from about 8 meg to 15 meg in size. So you immediately go away from this 1 gig size Debian image that you would have in Kali Linux, for example, to now having a really small operating system which you can then hide into the actual phone's memory without causing degradation on the actual phone in the long run. And then the next part is that we use a CPIO to be able to load and add this content to our phone. So in here, we've got a 32 meg operating system with Python, a VPN, a network stack, and a few more wonderful gadgets involved as well. And then what we can also do is say, right, we've got our small little package. What can we do to be able to just deploy it? We don't want people to become a software developer just to be able to do a red team engagement or just make a phone quickly. So we built scripts to be able to just, you buy your phone, you plug it into your laptop, you run the script, you've now got a red teaming device. Or you've got some form of covert device that you can use. But then we've also allowed to be able to have a remote operator on the back end. So if you're walking around taking pictures or using the functionality of the phone, you can have a remote operator on the back end. And then with the CPIO, we can get all these tools and we can do some weird and wonderful compression in the States to deal with forensic analysts. So one of the things that we found is that GZ compression makes it really interesting to stop data carving, which is a common practice in forensic analysis within mobile. But then because it's also read-only, if the phone is restarted or it dies, anything that's saved on the phone is then taken off. So if you're taking pictures, which are saved into this operating system, if you get caught or the phone inevitably does die, all the images are then destroyed. So if you do get caught, there's no actual evidence of you doing anything wrong. So I've talked about this little operating system, and what we've done is used what's called Cygen mod 13. So we've modified the phone to be able to do this rootable device. We've sideloaded it with the fact that quite commonly a lot of people will either run different operating systems like Ubuntu Touch, Lineage, which is the increase of it, and Sailfish. And it's quite common to see this. So if anybody does say, why have you got 2 operating systems on your phone, or why is your phone not using Android or Linux, you can say, well, I like to run 2 things at the same time. Everyone dual boots at some point in their life. So we get to that level of deniability that way. And then we can actually start developing our functionality. Because we've sideloaded this operating system, we can still use the Android device. We're not actually mangling any of Android so much to make it non-usable, because we actually want people to still use the phone. So what we're doing is almost making a wrapper around Android to be able to further our cause. So some of the functionality that we've used and developed is USB tethering. So if you're walking around a building, for example, a lot of the time people say, can I just charge my phone? It's a quite common question. But what is interesting is you can plug the phone in and the device will actually say it's charging, but what's actually happening is you're actually adding a new network adapter to the back end of your server or your desktop, and it'll start rerouting traffic straight through the actual device, out through a 4G SIM, and then to whatever VPN architecture you got at the back end of your network. We've also got the VPN, because we want all our data that's being exfiltrated to be all encrypted. We don't want to see people, like forensic investigators, to say, oh, they're taking out 3 images that they've taken on day X. So that's our process for that. We've got a gesture reader as well. So what we actually do is we've got Python sitting in this sideloaded OS, and it listens for the APIs within the Android device. So if you go across the screen, for example, it'll say, oh, that's hit these points in the screen, let's take a picture. But when it does that, the flash is then disabled. The screen doesn't light up or anything, so you could just go like that, and you could be taking loads of pictures, or you could be walking around with your arms to your sides, taking videos and turning the microphone on to record. And then finally, we've got the photo as well. So one of the things that we found is that when it comes to forensics, quite a lot of people try and do anti-forensics, and it's quite hard. And one of the main things that we find is there's about 3 or 4 generic steps when it comes to anti-forensics, or forensic investigation, sorry. And the first one's saying, right, when it comes to demonstrating an investigation, we need to first be able to get 2 images that we can work on. So the first image will say, right, we've got all this data with a checksum or a hash, and then we take the second image and then compare. So our hashes should be the same. Because our device is hidden in RAM when it's loaded, we can actually start editing parts of dead memory within the phone. So it starts to disable that part of the integrity check. So you won't ever get the same type of image at the end goal. So when it comes to doing, say, a court investigation, and you've been caught with the phone, their images will never marry up. So you get that level of deniability again. And this is a similar theme all the way through the phone here. The second part in an investigation is to then do a live analysis, and that comes down to using things like Cellbrite or other phone tools, which always apply to actually use the ADB bridge. But like I said earlier, we actually disable the ADB bridge from the outset. Because there's a remote operator, we can actually disable and re-enable the ADB bridge as we want. So we can start actually attacking the forensic investigator remotely if they're not using a Faraday cage. And we can start playing with some of their tools when they try and connect to us. So we can actually start being quite offensive in the long run. And then finally, when it comes to the last part of an investigation, if you can't actually find anything on the device, because there might be some form of protection in the long run, and you've done your imaging and it doesn't marry up, you end up doing a destructive analysis. So we actually take the chips off the back and we try and read the memory on it. But we go for a bit more of a caveman approach in that quite a lot of people don't actually think about taking the back slowly off. So we actually glue the back of the phone, the back of the chips to the back of the phone. So when you actually pull the back of the phone off, all the chips rip out, and now you've just lost all your integrity of a device. So we're game over at that point. So it was a bit of a caveman approach. We got a bit of a bit more of an intuitive way, a bit more interesting way, and then our caveman approach to really end it. Yeah. So I've got a video here. Hopefully, so what this is taking a remote picture from the phone without actually changing the device's front end. So I'll SSH into the phone. Oh, wait. There you go. I forgot I was looking at myself. So SSHing into the phone. Now I'm connected to the phone. We've got a set of scripts, one to disable the ADB, one to enable, one to the phone, and then we've got the USB Ethernet to be able to actually generate a remote connection. So what I'm going to do first is show that there is no images on the actual phone. So this will go into the actual operating system, the Android operating system. It'll check for any pictures, and then we run the photo script, which wraps around the actual Android APIs. And now we've taken an image, we've stored it into our side-loaded operating system, so at any point it doesn't actually hit the Android device. So it's now stored in our read-only file system at that point, or close to it anyway. So there's no actual end goal for the Android device to be able to store this in that actual operating system. And if at any point we just want to get rid of these images, we can either remotely take it off, so if you have a remote operator, or we can actually just turn the device off or wait till we get home to be able to either A, get the images or delete the images. So, and then in terms of our anti-forensics type attacks, so this one is to compare the ADB bridge and how we actually generate the connection. So, like again, I'm going to SSH into the phone. I got my scripts. So I'm going to check to see if any ADB devices are actually connected to my laptop. It says no, even though it is. So I'm going to enable it. And now I can connect to the phone again. So I've got my actual standard ADB connection. So I can connect to the device with a shell. I can start interacting with the back end of the device. But one's if I actually just don't want this to ever happen. So someone actually tries to generate the ADB bridge connection on the phone itself by clicking the developer screen over and over again. What I can actually do is start saying, right, okay, let's turn that off by just disabling the ADB. And now we've disabled ADB, so devices like Cellbrite won't be able to connect to the device anymore. So we can now start to play with the investigator in the long run. So what do we have? We've got an extremely small operating system where we can see that it fits into memory without actually compromising the overall Android device. So you can still use it to make calls. It still uses all the standard operating system that you would see. It doesn't look out of place when you look at it in person. The entire operating system is also hidden in the back of a file. So if you're looking for the actual operating system, the GZ compressed image is sitting at the end of another file. So unless you know where to look, it's quite hard to see where to begin, which is always a bit of a paradox. And then we can actually load and hide the running operating system all into the memory of the device, which is quite important because we just want it to die if we have a call. And then we can also wrap all of our functionality using Python all the way around all of the Android's devices. So we can actually turn the microphone on, we can mess around with the gesture readers like we've just done, and there's so much more you can do. So one of the things that became apparent is there's a lot to be done in this operating system in that we've got things like Kali Net Hunter, which is just the standard approach to doing sort of embedded device in terms of pen testing, where you've got this device, you've got all the pen testing tools, you're good to go. But there hasn't been a lot in terms of what other things can we do to further this cause. So throughout this, it's been apparent that SE Linux is really not your friend when you're doing development in mobile or embedded devices at any point if you're using Android. And then there's particular areas in memory within the Android device, and I'm sure there is in other operating systems as well, where you can actually hide a lot of your stuff. So what we're using in ours is the ATP reserved memory space, but Android has stopped using that. It's just there for legacy, so you can actually just hide quite a lot of things in there without ever being overwritten by something else. And then obviously the offensive development regarding embedded devices should be further improved quite a lot. So some of the future work, all of the source code for the device and all the tools and everything will be on my GitHub. There is an academic paper written as well. And then any updates regarding the project itself will be on our Twitter. A lot of it will be released at the end of the week, which should be nice. And there's my lovely silhouette as well. So thank you very much.
So we've just got some time for some questions, if anybody has any. Over at the back?
I don't have a mic with me. Yeah.
Yeah.
So when you're talking with the Android operating system, are you using role-playing the C files or
So when it comes to doing Android, using the Android operating system to be able to do, say, like using the camera and things like that, a lot of it is just used with Python connecting to the Android functionality. So the APIs that we've built to wrap around Android underline and hook into the actual Android's system call itself. So we can actually trigger that system call whenever we want. that. Yeah. So we're actually migrating to a Ch-ch-chroot. And so what we're actually doing is saying, right, let's just shell it into that operating system itself, not into the actual device, not into Android, sorry. Yeah. Cool. It can be, I think we use the latest version of Android at the time, and you can update Android as much as you want, so it can be on anything, yeah, any Android whatsoever. We did try and port it to a cheap Chinese watch, but the watch actually started to melt, so that wasn't good. Yeah. Especially when wearing it on your hand, it got really warm really quick. Yeah, you don't want to start doing crypto on your hand. It's bad. So, as in... Okay, so in terms of recording, so how can you constantly record when you've given it back the device? So when it comes to the tiny core, you can build and compile whatever tools you want into it. There's quite a lot of scripts. Because it's using Python in the back end, but you can use pretty much anything, you can add further functionality that way. So if you always want to trigger the recording whenever the screen lights up, you can look for the system call for Android for the screen lighting up, and then it can trigger the next system call to then record the device. So if you wanted something like, I always want to have the microphone listening. So anytime someone clicks the power button, because that's got a power ID within Android, it'll then trigger the microphone in the long run and start recording into the operating system. Into your Ch-ch-chroot. The problem is you just need to be careful about how much memory you're using to record something, because if it goes quite large, you're going to start noticing some triggers. Any more? If anybody has further questions, I'll be around all day, so if you do want to come see me, that'd be great. Cool. Thank you.
Another round of applause, please, for Jack.